Welcome to another session of our tutorials. Today we are going to look at robotics. So we are going to start by defining what robotics are, what we mean by robotics. Then we are also going to look at a little bit of history of robotics. Then after looking at a little bit of history of robotics, and also then we are going to look at what is it that robotics entails, and then we look at both the advantages and disadvantages, and later on we look at the components as we continue. So when we talk about robotics, what is robotics all about? So robotics is basically a science and engineering that is dealing with the study of robots. So it is basically science. It has got the science part and engineering that dealing with the study of robots. Dealing with the study of robots. And when we talk about the study of robots, then generally we are talking about four things. We are talking about the robot's design. We talk about robots manufacture. We talk about the robot's structural disposition. Disposition, and also the robot's application. So generally these are the four things that we talk about as far as the robots are concerned. So robots generally are control systems that attempt to regulate several positional quantities in order to achieve physical tasks to emulate human being. We know that it is the human being that carries out the task. So all this, a human being has got several physical quantities that are regulated in naturally, and the robot also just try to emulate some of these physical quantities that are there in order to achieve a task that is to emulate human beings. So the robot is supposed to help human being carry out its activities. So it has to work just like the human being, or it has to carry out some tasks that the human being may be in a position to carry out. So that is the main work of the robot. Like for example, you can talk about a robot that has got several physical quantities. Talk about a robot that is maybe moving, with the human structure, moving in the shop floor in order to carry out some activities like maybe picking the bolts and nuts that are fallen on the ground. Then this one must have the physical quantities like direction. We can talk of the direction. So we are going to we have to get a physical quantity of direction, and for this it must have its own sensor as well as its own actuator. Another thing that it is going to have, another physical quantity that we can talk about, that is the aspect of velocity or speed. That is the aspect of velocity or speed. So the velocity or speed will be very, very important because the robot will be moving. It will be moving in a direction, of course, and then after moving in a direction, it is going to have speed. Maybe you can make it in such a way that as it approaches the object, it moves with a lot of speed, but as it nears the object itself, the speed can reduce in order to enable it to pick the object. Another physical quantity that may be present in that case, you can talk about the touch pressure. The touch pressure, and the touch pressure here is what is going to enable it in order to carry out that particular object. Another aspect that is also very, very important, it should know when it is approaching that particular object. Another physical quantity, that is proximity. So all these four, just as an example, are maybe several physical quantities that can be in a robot. So basically we are simply saying that a robot is basically control systems that attempt to regulate several positional quantities in order to achieve physical tasks so as to emulate human being. So that is what we can talk about as far as the robots are concerned. I want us to look at a brief history of the robots, and maybe we can talk about the brief history of robots. So when you talk about the robots, the history of robots. The history of robots was coined by somebody by the name Isaac Asimov, and this one was in his 1941 science fiction story, Liar. The stories of artificial helpers and companions and attempts to create the robots also have a long history. The word robot comes from the word robota, meaning in Czech Republic, forced labor or drudgery. You realize that in the robots, the fully autonomous robots only appeared in the second half of the 20th century. And the first digitally operated and programmable robot, that is called the Unimate, was installed in 1961. And the main work of this particular robot was to lift hot materials or to lift hot pieces of metals from a die casting machine and stack them. So in that case, the robots were supposed to be used in carrying out dangerous activities that cannot be done by a human being. And as we can see, the first robot, the Unimate, was used in order to lift hot metals in a die casting industry. Then nowadays, as we can say today, there are commercial and industrial robots are widespread, and they perform several jobs that more cheaply as well as accurately and reliably than humans. They're also employed in jobs that are either too dirty, dangerous, or dull to be suitable for humans. Robots are widely used in manufacturing. So the areas of application of the robots, we can talk about manufacturing, assembly. You can also talk about packing, transport, earth and space exploration, surgery, weaponry, laboratory research, and also safety. Also, they can also be used in mass production of consumer and industrial goods. And maybe if you make a reference to the site EEES.education, you will be able to get materials that defines history of the robot, first by the date, the significance, robot name, and the inventor, in that order until we have the latest robot, that is the Puma, that was used in 1975, and also some of the latest are still being produced in order to help human being carry out tasks, or to emulate human being in order to help him carry out tasks. So now we are going to look at what is it that we talked about. So generally, the robots usually try to implement what we call the digital, not real digital, but direct digital control. Direct digital control. So they usually make use of the direct digital control, and in the direct digital control, we can talk about, get the block diagram in order to show the several physical quantities. So we can talk about the direct digital control, and that is the diagram, whereby this one now is actually the process, and it is surrounded by several sensors. You can have several sensors there. Maybe you can have 3 only, but does not mean that they are going to be 3. We simply say that we are going to have several physical quantities. So in that case, we can talk about maybe 3 sensors there. And then this one should go to what we refer to as the multiplexer. So we talk about the multiplexer here. Talk about the multiplexer. So we are going to talk about the multiplexer. The multiplexer should go to the DAC. So we can have a DAC here. So we can talk about this. We can talk about the DAC here. So this is just the diagram of direct digital control. So we have the DAC. Then the DAC, not really, this is multiplexer, so we are having the sensors. So the sensors are not going to go to the DAC, but rather we are going to have ADC. So from there, we also have this. So in these ones, we've talked about them as sensors. Then here down here we have what we refer to as the actuators, or we can talk of them as final control elements still. So here this one is going to go to the demultiplexer. We have the demultiplexer here. Here the demultiplexer, and again the demultiplexer, we can also have DAC that is going to convert them into digital before they get into that process. Then from here, all these ones are supposed to work in some order, in the same obedience. So, and then from here we can have the CPU, or rather the digital computer that we are going to use, CPU. So we have CPU here. So here we have what we call programming console, whereby we are going to have the programming console. We call this one programming console. Then the programming console, of course, that is going to be that way. Then we are going to have the databus. The databus, and again another databus. We have the databus here in that case, and then of course there has to be communication here. That is going to be the control and the address bus. We're going to have the control and the address bus. So that is what we can talk about as the digital, direct digital control. So if you look at the direct digital control, we can talk of, we talked of the robot working on the basis of trying to regulate a control system that tries to regulate several physical quantities. So in this case, each and every physical quantity must have its own sensor. So we have the sensor there. So we have 3 sensors. Maybe we can talk about a system that is controlling 3 physical quantities. Then after that, you'll find that each sensor usually each sensor will monitor a specific variable or variable at specific point of the process. So we have several physical quantities, each one having its own sensor, and the work of the sensor is simply to monitor specific variable or to monitor a variable at specific point of the process. The many signals that we have there will be sampled by the multiplexer, and as we all know, the multiplexer is a rotating switch that is going to make in regular turns and direct each signal to the ADC. So when the sensor for maybe a physical quantity, we can talk about the speed, when it makes there, it will be what goes to the ADC. So we are simply saying that the sensor, that the many signals that are sampled by the multiplexer in regular turns, which in regular turn will direct it to the ADC. Then the digital signals are used by the computer, and the computer can be a microprocessor-based system in order to do a comparison against the set points in the computer process control program. So here in the computer, we are going to look at the difference, or rather, we have the set point for each physical quantity, and it is going to compare those particular set points in order to have appropriate signals that are sent to the actuators to control the process. The signals from the computer will go through the demultiplexer, which then channels them, which will again channel each signal to its appropriate actuator. And this one will happen in obedience to the sequence of original multiplexing. The synchrony will always be enabled by the address and control signals in the address and control buses. So that is what is going to, so the CPU will be able to know which of the sensor has sent the signal, because there is a program that is going to compare what is the set point for each physical quantity, and therefore that it is important for the CPU to know each and every sensor and identify them in order to bring about the control. So that is why it is very, very important to synchronize the systems, and that is why we say that the synchrony is enabled by the address and the control signals in the address and control buses. So we are going to look at the advantages or the benefits of robots. So what are the advantages or the benefits of robots? So we are going to look at them in terms of, let's talk about 4 advantages, and then we are going to explain. So we can have the advantages. The first one, we can talk of the quality. The second one, we can talk of the advantage in terms of production. The third one, we can talk of the advantages in terms of safety. And fourth, we can talk about the advantage in terms of savings. So we are going to look at each and every advantage with a brief explanation for each. So the first advantage that we're talking about is the quality. So we'll find that the quality of work that will be done by industrial automated robots usually is better than what can be done by human beings. So you'll find that the industrial automated robots usually have the capacity that in order to dramatically improve the product's quality. So in this case, the applications are usually formed with precision and high repeatability every time, and the level of consistency can be very hard to achieve in any other way. So in this case, when you talk about the quality of the work, maybe after you have maybe set a certain the way it is supposed to be produced, then the quality of the work will be done with a lot of precision. And this precision will bring about the consistency that is very difficult to achieve in any other means. Maybe you can talk of the human being. So that is why we talk about one of the benefits as the quality. The second benefit or the second advantage that we can talk about is the production. When you talk about the production, with the robots, usually have high throughput speeds, which will increase, and this one has got direct impact on production. Because robots can work continuously without a break, vacation, sleep, and it has a potential to produce more than human worker. So you'll find that when we talk about the production, the robot can produce continuously without a stop, and that one will have will have a great impact as far as production is concerned. The third one, we can talk about the safety. You'll find that the robots usually save workers from performing dangerous tasks, and it can work in hazardous conditions, so with poor lighting, toxic chemicals, as well as tight spaces. And they are also capable of lifting heavy loads without injury. And this one will usually make the workers to move to supervisory roles, which where they no longer have to perform dangerous applications in hazardous settings. Again, another thing that still under safety, another thing is that the robots may also increase the worker's safety by preventing accidents, since humans are not performing risky jobs. So in terms of safety, we can see the robot in that manner. So it brings about safety by making human beings taking supervisory role, eliminating, making human beings not involved in risky jobs, and that one will make the robots, we will make safety to be achieved. Another important advantage that we can also talk about is the savings, because at the end of the day it is business, so it is going to improve the workers' safety, and this one leads to financial savings in terms of the health care and insurance concerned to the employers. Again, the robots also offer unlimited performance, untimed, not unlimited, but untimed performance, which saves valuable time, and their movement are always exact, and this one also minimize material waste. So when you talk about the savings here, we are looking at it in terms of the insurance cost that it will reduce as far as the company is concerned, and again, another one, we can also talk about it in terms of minimizing waste. So the movement is always exact, and that one makes it to minimize waste. So in that case, it will have saved the company a great deal in terms of the finances. Now we can talk about the disadvantages. So what are the disadvantages that we can talk about? I'm only going to talk about 3. One of them is the expense. 2, we can talk about, after the expense, we can talk about the return on investment. return on investment. And thirdly, we can talk about the expertise. So those are the 4 disadvantages that we are going to talk about. Maybe just to have a brief explanation for each of the disadvantages. The first one, we are talking about the expense. So when you talk about the expense, then you realize that the initial investment that is to integrate an automated robot is always significant, especially when the business owners are limited their purchase to new robot equipment. And again, you also have the regular maintenance that will also increase the cost further. So when you talk about this particular expense, that initial cost that you are going to incur in order to bring about the robot, to automate the control is always very huge. And in that case also, the robots are also made in such a way that they will also require regular maintenance, and that one will make it a little bit expensive. Another one, you can talk about the return on investment. When you talk of return on investment, then incorporating industrial robots usually do not guarantee results, and therefore without a proper planning, the companies may have a difficulty in achieving their goals. So our installation of robotic equipment is not a guarantee to high profits, because the investment will be heavy. So it is not very, very easy, especially it does not guarantee the results. Again, the other one, we can talk about the expertise. So because of the robots, they are always specialized equipment, and therefore they will usually require a training program in order to interact with the robotic equipment. They usually require training, so you will have training programs for the technicians. And this one, the training program for the technicians usually take time and also financial output as well. So basically, those are some of the disadvantages of the robot. We may have not exhausted them all, but they will also help you in order to come up with more disadvantages.